All right, this is the podcast review for Physical Science 8th grade, Unit 1, Chapter 4, regarding solutions. The very first thing you need to know is the definition of a solution. Remember, the definition of a solution is it's a type of mixture that is the same throughout. It has the same amount of each element throughout the entire solution. It can be physically separated, but you're not going to change the solution in any way. You'll also need to know the definition of a solute. Remember, a solute is the substance that is dissolved into the solvent. For example, this would be sugar and this would be water. Remembering that water is the most commonly used solvent. It is also the most important solvent, and when the solute and the solvent are combined together and the solute is dissolved into the solvent, then you're not able to tell the differences between the two. They are that combined. Okay, the properties of solvents change when they're in a solution. So the solutes change the physical properties of the solvent. Solutions' physical properties differ from the physical properties of the pure solvent. And the amount of it determines the change. One of those changes is the lowering of the freezing point. All right, the freezing point, remember, is where the solvent becomes a solid. And so if we have water, let's get some water, good old H2O, which freezes at the point of 0 degrees Celsius. If I add a solute, it's actually going to take this number and it's going to lower it, so it's going to be below 0 degrees Celsius. All right, so one way that this is used in everyday life is that road crews will take a solute, in this case salt, and they will actually spread that out on areas where it's expected that the roads and sidewalks are going to get icy. And so that salt, what it does is it changes the water that is sitting there and lowers its freezing point, so that as the weather gets colder, the salt is going to keep that water from freezing, or at least lower the ability of it to freeze, which is going to make roads and sidewalks safer. Now, all of this also applies to the boiling point. So remember that anytime you add a solute to a solvent, it's going to lower its freezing point. It's going to raise the boiling point. So just like with the lowering of the freezing point, if we have a boiling point up here, it's going to raise it even higher. All right, when it comes to working with solutions, the first thing you need to remember is the definition of concentration. Now, a concentration depends on the amount of the solute dissolved in the particular solvent at a particular temperature. A solution with only a small amount of dissolved solute will have a low concentration, and as more solute is dissolved, the concentration gets higher. Remember the definition of a dilute concentration. A dilute concentration is one that has very little of the solute. While a concentrated solution has a lot. When we're talking about concentration or concentrated, there actually are two different types of concentrated. There is a saturated solution. Now, a saturated solution, that's going to be where it contains the maximum amount of solute that can be dissolved in the solute at that given temperature. Remember, that is at that given temperature, and it's the maximum solute. There is one other option here, and that is a super saturated. And this is where, just like with the rock candy liquid, what we did is, or I did, is to add more solute than is possible at its normal temperature, and then that is done by raising the temperature. So by increasing the temperature, you increase the ability of the solvent to take more of the solvent or solute in. All right, next up is how solubility is affected by molecular structure. Okay. When a substance dissolves, remember its molecules or ions actually separate from each other. So if I have, let's say NaCl, okay, these are actually going to separate away from each other, and they're going to be evenly mixed with the molecules of, say, water. And so you're going to get lots of water around with Na pluses and Cl minuses gathered throughout the solution. Water, which, as we said earlier, is the most important and the most common of all solvents, it actually is a polar covalent bond, and so the result is that those water molecules, they have a negative region and a positive region. So if I have my H2O molecules right, there's a negative part and a positive part, and so they're said to be polar. The molecules of oil, however, these actually are nonpolar. They do not have a positive or negative region, and so that makes oil insoluble in water. Because these guys are polar and the oil is nonpolar, they actually are not going to be attracted to each other, and so they're going to stay away from each other. Remember the saying, like dissolves like. So polars are going to stay with polars, nonpolars are going to stay with nonpolars, and they will not mix together. All right, last section is regarding acids and bases. So acids and bases. Remember that acids are found in foods and so forth, but they taste slightly sour when they dissolved in water and produce a burning or an itchy feeling on the skin, while bases are the opposite of that, and they tend to taste bitter rather than sour and often feel slippery to the touch. Just a quick reminder of what's an acid and what's a base. Remember that these only happen when they are dissolved in water. At no time when they're outside of the water are they considered an acid and a base, only when they're dissolved in the water. Okay, remember that acids here, they are able to donate a hydrogen ion. So they are a hydrogen ion donor. That is that they have another proton and they actually are able to give that to another substance. Bases, however, are the opposite. They actually are looking for hydrogen ions. They actually can accept them. So they accept hydrogen ions. So one more time, acids are the donors, while bases are the receivers. And when these combine together, let's change that to red. So when these combine together, so when this guy donates and the bases accept, it actually produces H2O. Okay, characteristics of acids. So back to acids here. Remember that when they react with a carbonate, they produce CO2. And when they react with a metal, they're going to produce hydrogen gas. All right, and then there's also bases. Now, they have their own characteristics. They're going to make food taste bitter, and they're going to feel slippery. And when they feel slippery, that's because the base actually reacts with the fatty acids on your skin, which causes soap to be formed as you're washing your hands and such. One more thing back to the hydrogen gas. The reason it produces hydrogen gas is this is actually released from within the acid. Alright, this is the pH scale, and so this goes all the way from 0 down here, all the way up to about 14. 7 is a neutral. Pure water is a neutral at 7. Bases are up here in the above 7 to 14 range, and acids are down in the 0 to 7 range. So the last thing you need to know is that as you're reading this scale, if I were to give you an item and tell you that its pH scale was a 3, you need to know that that means it's an acid. If I were to tell you that its pH scale were 11, you need to know that that's a base. And that is the end of the review, and as always, as I always end these, just a wish for good luck on the test.